Okay, so the assignment that is due tonight, we'll make that due Monday, 5:13 by, well, yeah, Monday, 5:13 by 9 p.m. Section P4 that was supposed to be due Tuesday.
Today is the 13th.
So that's Monday. What's Monday? The 17th. And
Yeah.
section P4 was Tuesday. I think we'll be able to keep that. Guys, again, if you would please turn on your microphones and speak rather than using the chat, things will go a little more smoothly. Section P4, well, we'll leave that on Tuesday. So let's, and then the WebAssign assignment, oh, we'll just make it Wednesday, it's fine. So this will be due Wednesday.
Can you share your screen?
Yeah. WebAssign will be due Wednesday, and we'll make P4 due Wednesday as well. And everything is due at 9 p.m. All right, for every assignment that's due, the due date will be 9 p.m. The time will be by which it's due will always be 9 p.m. All right, so back to section P2 or P3. So we did, several problems yesterday. Here they are. Are there any other problems in this section that anyone would like to see in P3?
Sorry, just to clarify, for P4, did you say it was due Wednesday or Thursday?
Wednesday.
Wednesday. Okay, thanks.
Yeah, right here. Okay. Let's move on to section P4 and continue our discussion there. It's a short one. And then we'll do a few problems in here, which are like stuff in P3 as well. So we were defining the square root of a and what that means. The square root of a equal to b means that b is the positive real number such that a is equal to b squared. So defining the square root of b in terms of integer exponents. So for example, square root of 9 is 3, square root of 3 squared is the same as the square root of 9, it's 3. The square root of negative 3 squared, negative 3 squared is 9, and the square root of 9 is 3. So more generally, what I'm getting at by these two examples here is that the square root of x squared, we don't say it is x. The square root of x squared is the absolute value of x in order to keep it positive. Okay, so this will be important later on, so that's something to remember. Other examples, square root of 4 over 25, it's 2/5. Square root of 0, that's just 0, right? So on and so forth. For an even number, n, even integer n, positive as well. This thing here, the nth root of a equal to b, means that, okay, b is the positive real number such that b to the n is equal to a. Okay, and again, when you're talking about and that's called nth root of x to the n, for even values of n, it's equal to the absolute value of x, because you need to keep it positive. So a similar sort of example would be like this. The fourth root of 81. Well, 81 is 3 to the fourth power. Right? It's 3 times 3 times 3 times 3. Right? 3 times 3 times 3 times 3 is 9 times 9, which we know to be 81. However, right, the fourth root of, say, negative 3 to the fourth is again equal to 3, because minus 3 to the fourth is again, well, it's minus 3 times minus 3, minus 3 minus 3, which is again positive 81. So you have this problem again with a positive number to an even power and the corresponding negative number to the even power, giving you the same result, in this case 81. So we have to have that same convention that the nth root of x to the n is the absolute value of x when n is even. When n is odd, the nth root of a is equal to b means that b is the real number such that b to the n is equal to a. Now there is no problem with with distinguishing between the positive and the negative when n is an odd power. Okay. The third root of 8 is 2, because 2 to the 3 is equal to 8. The third root of negative 8 is equal to negative 2, because negative 2 to the third is minus 2 times minus 2 times minus 2 is minus 8. Yeah, on the syllabus. Okay. Again, guys, I would ask you to please turn on your microphones and just speak freely. Okay, so now that we have this notion of what an nth root is, okay, we are able to define the power of, well, we're able to define exponents for any rational number. Now, we define, Okay, a to the power 1 over n for any integer n, any positive integer n, as a to the 1 over n is equal to the nth root of a. Okay, so for example, a to the 1/2 is the square root of a to the 1/3 is the third root of a to the 1/4 is the fourth root of a, so on and so forth. Actually, this is the preferred notation. One does not use this notation too often. Okay, except for just n equal to 2, the ordinary square root. So actually, one hardly ever uses the notation nth a. It is preferable to write a to the 1 over n, except in the case where n is equal to 2. So the square root symbol gets used plenty. Okay, and now for any rational number p over q, a to the p over q is equal to, well, it's defined to be a to the power p qth root. Or, the same thing, the qth root of a to the power of p over here. Okay, again, this is the preferred notation. This notation is about, either one of these is about as clunky as it gets.
So does that include negative numbers?
Yes. Well, with the negative numbers, then for any rational number p over q bigger than 0, okay, when p over q, I'll do this, and a to the p over q for the negative rational number is then just 1 over a to the p over q positive. Okay, so just like with integers. So a to the 2/3 is 1, a to the negative 2/3 is 1 over a to the 2/3. And now all of those identities that worked with integer exponents, they still work with rational exponents. So, number 1, a to the p over q. Well, let's say ab to the, zoom in a little bit, p over q is a to the p over q, b to the p over q. So we looked at this before where, we just had an integer exponent. A, b to the n is a to the n, b to the n. So it still works when you have a rational exponent. 2, so we talked about exponentiation distributing over multiplication and over division, and it still works here. Exponentiation with rational exponents still distributes over multiplication and division. the bit about adding exponents when you have the same base. So a to the p over q times a to the m over n. Still the same thing, p over q plus m over n. 4. This one as well, a to the p, the thing about subtracting exponents. A to the p over q over b to the m over n is equal to a to the p over q minus m over n. 5, the thing with the negative, and then again with this one, this identity, we don't really sort of use it as much.
Wouldn't that be only if they're both A?
Oh, I'm sorry, yeah, both A. This identity, we don't use it as much. We more so think of it like this. So the related identities. When you have, say, b times a to the p over q over c times a to the m over n, we think of this, by canceling. We cancel this, and then we subtract it from that. All right, so this becomes b a to the p over q minus m over n over c. That's how that identity gets used more often. So you can cancel on the top, or you can cancel on the bottom. Or b over c a to the m over n minus p over q. All right, so we think of canceling common factors on the top and bottom, and that idea gets used more often than just straight using this one. So related, so we'll call them cancellation identities. And then there was this one as well. A to the minus p over q is equal to 1 over a to the positive p over q. We already talked about that. And then this one as well. A to the p over q to the m over n. So when you have nested exponentials like that, then you just multiply. So each one of these identities, we talked about them with integer exponents, but they still work with rational exponents. Okay, so let's take a couple quick examples in the last minute or so. So let's.
Could we do one similar to number 68 on section P4?
Similar to 68. That's the one I assigned for handing in.
Yeah.
Yeah. Maybe we need to start out a little slower, perhaps. Let me see, which is 68. Yeah, I wanted to start out with a few, slower examples, but we'll pick up on those examples on Monday, and then we'll get to that. Like I'll do number 67, which is right before 68, which is pretty close to it. So how about this? So the third root of 108 minus the fifth root of 32. Okay, well, what can we say about the number 108? Well, 108, we know it's 4 times 27, right? And then the 5th root of 32, well, 32 is 2 to the 5th. So this one is just 2, right? 32 being 2 to the 5th. Actually, maybe let's not do 108. Let's make it a little bit more. 108, 216. So 216, that is actually 8 times 27. Minus the 5th root of 32, 32 being 2 to the 5th. So the 5th root of 32 is just 2. And then, again, exponentiation, right? This third root is an exponent. It's an exponent to the 1/3 power. So this is equal to 8 times 27 to the 1/3 power. You can skip that step, but, we'll put it in here. And that distributes over multiplication. So that's 8 to the 1/3 times 27 to the 1/3 minus 2. Well, 8 to the 1/3, that's the third root of 8. That's, again, 2. 27 to the 1/3, well, 27 is 3 to the 3rd. Right? So the third root of 27 is 3 minus 2. Oops, minus 2. So that's 6 minus 2 is 4. Okay? So that's it for today. So on Monday, we'll go over, some more complicated examples for this section, and then hopefully move on to section P5. Okay, so email me with any questions or concerns, and remember the assignment due dates have been changed, and I'll post all this to the website and the video lecture to YouTube. Okay.